In the previous lesson, we pretty much graphed sine and cosine with singular transformations. In other words, we changed the amplitude, or we changed the period. We changed a translation, either left and right or up and down. But we never really got to combining everything, and that's what we're going to do today. We're going to mess around with all the transformations of a function. So the first thing we do on all of these problems is we're going to identify if it's in the right form. And currently now, we need a coefficient of 1 in front of this x. So we're going to have to factor in this case. In doing so, we get the sine of 3 times the quantity of x minus 20 degrees. And you're going to have to get used to going between degree measures and radian measures. So now I can identify some things. I know A equals 1. I know my period is equal to 360 over 3, which is 120 degrees. I know my intervals are 120 over 4, or 30. I know I have a phase shift in this case of 20 degrees to the right. So what I'm going to do is I'm going to take and I'm going to start my graph normally where 0 would be. So that's at 20 now because I've slid everything over. My 0 slides to 20. If I need to, I'll just put this 0 here, cancel it out. And then I'm going to graph intervals of 30 degrees from that point. All right, so I go to 50, 80, 110, and finally 140. And then I look from 20 to 140 and say, do I have 120 degrees? I do. Next, so what I've dealt with basically is I've dealt with my period change and my phase shift. Now I have to check to make sure my amplitude's the same, which it is. So I'm going to go from 1 to -1, and then I'm going to graph a regular sine function. First interval is 0, goes up to 1, back down to 0, -1, 0. And just like in all of our other graphs, when we're doing multiple transformations, you should probably check. So I'm going to plug any of these points back into my original. Let's take 50 degrees, okay? So I have the sine of 3 times 50 minus 60. All right, so that's 150 minus 60 equals sine of 90, which equals 1. Check. Now we move on to radian values. So I will take and again factor. I have cosine of 2 times x plus pi over 4 in this case. I have my period equaling 2 pi over k, which is 2, or pi. My intervals are pi over 4. My phase shift, in this case it's in terms of radians, so it's positive here, but it has to follow a negative, so that's minus a minus pi over 4. So we have pi over 4, the negative type, which means it goes this way. Again, I'll take my 0, but cancel it out and put a pi over 4 negative right there. I have no amplitude change, so I'm just going to change all my values on the horizontal in terms of pi over 4. So this goes to 0, pi over 4. I'm going to go 2 pi over 4, 3 pi over 4, and I look from negative pi over 4 to 3 pi over 4. That gives me a total of pi, so one period of cosine is going to appear there. I throw in my amplitude values and I graph cosine. Like so. And again, I'm just going to check a value. Let's use 3 pi over 4 and 1. So I'll say the cosine of 2 times 3 pi over 4 plus pi over 2. And this is 6 pi over 4, which is 3 pi over 2 plus pi over 2. Taking the cosine of that, which is the cosine of 2 pi, which I know to be 1. Checked. So now we have a period change, phase shift, we've got a vertical translation, and a amplitude change as well. So everything's happening here. So let's identify A is equal to 3. We have a factoring to do. Let's say that's 3 sine of pi times x minus 1/3 plus 1. So now I know my period is equal to 2 pi over k, which is pi or 2. My intervals are equal to 2 over 4 or a half in this case. My phase shift is 1/3. Knowing that, I'm immediately going to change things to, you've seen this before, 3/6 and 2/6. So we'll add nicely. And I have a midline of now 1 because this identifies as a translation up of 1. So let's go ahead and draw that midline to start with. Put this up here. Call this value a 1. We'll label a few things now. I know this is 1. I have an amplitude of 3. So from that midline, I'm going to be going up 3, which puts me at 4 and down to -2 as such. I have a phase shift of 2 pi over 6 to the right. So I'll start at 2 pi over 6, 2/6. And then I'm going to add 3/6 from there. So this is 5/6, 8/6, 11/6, and 14 over 6. Check between 2 and 14, that's 12/6, which is 2. And then I will graph from my midline now sine. So this is like my 0. We go up 3, back to 0, down 3, back to 0. And there's my new graph. And again, let's just check. Let's check. How about 11? And at this point, I'm pretty positive this is all going to check out. But you're welcome to do it, and I suggest you do it on any assessment. So this problem looks to be a little bit more involved. We're going to go about the same process of putting it in the correct form first by factoring. Pull out a pi over 4, left with x plus 6 minus 4. I notice I have an amplitude of 2 with a flip. Period is equal to 2 pi over 4 or 8. Intervals 8 over 4, which is 2. Phase shift 6 to the left, and midline -4. So let's go ahead and draw some of this in right now. We've got our midline of -4. Let's call that right here. And you can start plugging some other things in. Say this is -4. I'm going to go an amplitude of 6, so I better have a 2 over here and a negative 10 down here. And then my starting point instead of 0 is going to be a negative 6 on the horizontal. And I'm going to take and go in intervals of 2 from there. So this is negative 4, negative 2, 0, and 2. And between negative 6 and 2, I have 8. So one period of cosine is going to appear there. I think I said I had an amplitude of 2, so why I did these I'm not so sure. All I need is a negative 6 and a negative 2. So I'm going to graph cosine from there. Normally cosine on the first interval is a positive, but I'm flipping. So I go here. I then go to 0, up to 1, back to 0, and down to negative 1. And there's my graph. And again, checking is entirely up to you. I caught myself midway, but you may want to start plugging back in. Let's just continue practicing. So now we shift gears a little bit. We're asked to write the function. It has an amplitude of 2 and it's a cosine function, so I'm just going to plug it in as I know it. That's 2 cosine. I have a period of pi over 6. So if pi over 6 equals 2 pi over k, I'll do a little work with that and I'll say that k equals 12 pi over pi, or 12. So I'll put a 12 right here. I have a phase shift of negative pi over 10. So in that case, I will take and put my x here and go plus pi over 10. And then my midline is at 5, so I'll add 5. So now we're going to write the equation of a sine function based on the graph. A couple things I know about sine. Number one is that it usually starts at 0 and then goes up. So I could start here, here, or here, which means I could have multiple different answers for this, but I would start at one of these 3 places if it were me. Then I know from here to here is a cycle of the sine graph. And then all I have to do is count 1, 2, 3, 4, and that's my period. So 4 equals 2 pi over my k value. Therefore, k is equal to pi over 2. So what I'm going to do is start writing my equation down here. I'll say y equals the sine of pi over 2, open that guy up, put x. Now I can tell you that the amplitude has changed, because from the midline, and I've drawn that in right here, I go up 1, 2, 3, 4, and down 1, 2, 3, 4. So if I choose this point as my phase shift, which I think I'm going to do, my amplitude is going to be 4. Since I chose this point as my starting point, I'm going to say my sine graph went backward 1. So if it goes backwards, I have to use an addition sign here. And I also notice my midline is no longer at 0, it's up at 2, so I add 2. And really that's all there is to it. You take it in small chunks. And that's all we've got for today. We'll chat again next time.